Hello, so I'm just going to go through the homework for week 6. It was the homework for over the Christmas break. There's just 2 questions for today, and they're a little bit complicated, so don't worry if you had a little bit of trouble figuring them out. But I have the solutions here, and I'm just going to go through them step by step in case anyone had any problem with any bit of it. So I'll just start with question 1. Write a function that simulates a sequence of coin flips and returns the number of flips performed until the first occurrence of 2 consecutive heads. Use the randint function from Python's random module to simulate a single coin flip. Perform a maximum of 1,000 flips. If 2 consecutive heads have not appeared by that stage, return 1,000 as a result. Note, a return statement can appear anywhere within the body of a function. It will cause the function's execution to cease, even from the middle of a loop, and for the indicated value to be returned. So there's a few ways you could have done this. I'll go through the way that I've decided to implement it and then all the ways that you could do this. So of course we're going to start by importing random because we need to use the randint function down here. So we have defining our function, coin flip, and so we're just going to initiate a variable to keep track of what the last flip is, because of course we need to say, what is it here? 2 consecutive heads. So we need to know what the current coin flip is and what the last coin flip was. So we're just going to set that to nothing for the moment because we're on the first one. So for I in range 1,000, which means we're going to repeat the code that's under this for loop 1,000 times, like the question said. So we're going to flip, so we're going to say random.randint 0 or 1. So we're just going to, I just chose the numbers 0 or 1, and I'm just saying down here 1 is equal to heads and 0 is equal to tails. You don't have to do it like that. You could just say if flip is equal to 1, just take that as a heads, and you don't have to do a second if loop down here, but I'll just explain the way that I did it. So we're setting flip to be 0 or 1 randomly. The computer will pick that. And if it's 1, we're going to set it to heads, and if it's obviously 0, we're going to set it to tails. And then down here, we're going to have a little check and say, okay, we know what the current flip was now, and we have the last flip. Let's see if both of them were heads. So if flip is heads and last flip is also heads, then we're going to stop. We're going to return the function. We're going to say, okay, we're going to end this now, and I want to return this. So this is basically saying, the question wanted us to say how many flips it took for 2 heads to come up. So we're going to say the number of flips until 2 heads was I plus 1. So I plus 1 is up here. So we're saying for I in range. So the first time we run this loop, I will be 0, and then it will be 1, and then it will be 2, and then it will be 3. But because I starts at 0, obviously we can't have flip 0. We're just going to add 1. So for example, if on flip 3, I would actually be 2 because we've done 0, 1, 2. So we just want to add 1 to make sure we're showing the correct value. And then let's say we get here and flip is heads and last flip is actually tails, or last flip was nothing because it's our first flip. Then we'll just continue on and we'll say last flip is equal to flip. So what we're doing there is we're setting last flip to be this current flip so that when we go back around and we do another coin flip, that we're comparing it against the new last flip, if that makes sense. So then basically if we go around this 1,000 times and nothing happens, there's no 2 heads, then finally we will return 1,000 like it says to do in the question. So yeah, I think that's question 1 all done. I'm just running it down here, just saying run the function, and that's just all the code there. Yeah, so that's question 1, and now I'll just move on to question 2. So question 2 was a little bit tricky. So question 2 was write a function donut that takes in the input here n that displays an nxn donut pattern as illustrated below. So for example, n is equal to 9, 9 times 9, so there's 9 columns here, so there's 9 little equal signs across, and then there's also 9 rows. And the donut, basically means that there is a little hole in the middle of the 9 by 9 square. It doesn't really look like much of a square here, but if you do it out on a normal Word document, it should be like a square. And the little thing here says the border around the perimeter should be a third integer part thereof in width. So that might be a little bit confusing, but what that means is that this whole bit here is a third by a third. So this one's 9, so a third of 9 is 3. So there are 3 rows here, 3 rows here, and then 3 columns on either side of either side of the whole. So there's 3 here, 3 here, 3 here, and 3 here. So it's basically, the whole is a third of the donut. So might be a bit tricky to figure out how to get started. But so the first thing we want to do is we need to print this out in sections. But we need to figure out which section we're in. So we have defined our function here, donut, n. So n will be, for example, 9 or 16 or any number that the user will input. And we first need to figure out the end of the first third. So it's n, and that's integer division 3. So integer division is when you get rid of the remainder. You just divide and just make it a whole number. For example, here it works out fine, n is 9, but if n was 8, you might get kind of a long digit number. And this one's saying, no, I don't want that long number, just give me the number that you're calculating and just get rid of the remainder, get rid of that decimal point. So the end of the first third is n divided by 3, for example. So that would, for example, in n equals 9, that would be 3. And the end of the second third is n integer division 3 times 2, so that would be 6. So the reason that this is important is because we're going to be printing this donut in 3 different sections, and we need to figure out where the 3 thirds are. So just before I start the code, I'll just show you how we're going to be printing this. So what we're going to do is we're going to print this third first, and then this third, and then this third. So obviously the middle third is the complicated one that has the hole in the middle. So we're going to want to check for that first. So first we loop for I in range n. So that would be for I in range 9, because we were going to have 9 rows going down. We want to say, okay, is I greater or equal to then the end of the first third, or less than the end of the second third? So we're saying, is that in between 3 and 6, which would make it this part of the thing here. So that's rows 3, 4, 5. We're basically saying, is it rows 3, 4, 5? And if it is, we're going to go in here and we're going to loop one less because we'll handle the last character differently. So basically these 3 rows are all going to print the exact same. We're going to want to have 1, 2, 3, gap, 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 1, 2, 3, and then a new line. And then 1, 2, 3, gap, 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 1, 2, 3, and then a new line. So that's what we're doing here. So first we're saying, is it... So then we always want to make sure we're checking for the weird case before we do what it should normally do. So we want to say, okay, now we're just thinking about the individual lines. Are we saying, okay, are we in this gap? So if we're in the gap, J would be less than the end of the first third and greater than the end of the second third. So that's saying, we're saying, okay, we're in this gap bit of this line. I know it's a bit confusing with the nested for and if loops, but try and stay with me here. So if that's the case, we're going to print a blank, and then end is equal to 2 quotation marks. That might be a bit confusing. So basically what that is saying is just every time Python prints something, it will automatically print a new line. But we're saying, no, we don't want to print a new line. We just want to print a space. And the next time we print, we want it to print right next to it. So we're saying, just have the end be nothing. Don't do a new line, just be nothing. So that's just what that little end thing is. You might see it in a couple of the print statements, so just keep note of that. And then, so we're like, okay, we're in. So this for statement is like, okay, are we in the second third? If we are in the second third, are we in the gap? And then if we are in the gap, print the gap. However, if we're not in the gap, just print a little equal to sign. So that will print just these 3 and then these 3. So that's basically the second third printed there. And then for the very last one of the row, so for example, this one and this one and this one, we want to print just an equal to sign. Now, the reason that we're printing just an equal to sign instead of including it in here is because of the end thing that I mentioned before. So you could also say end is equal to, and then this is the character for printing a new line. However, Python does that automatically. So you can just say print equal to, and it will say, okay, you want me to print an equal to, and then a new line. And that was basically what moves us on to the next line. So now that we've printed the complicated second third, we can go on and print these two big blocks here. So we're saying, okay, we're not in the second third, else, so we move on to this else statement down here, and we say, okay, for j in range n minus 1, just print the equal to sign. Just print it for that many times, but we're doing minus 1 because we want to do the last one with the new line. So for example, here, let's say when we start it, it will go, okay, I in range n, I is 0, so it's not in the second third, while we see in the first third or the third third. So we're just going to print an equal to sign 8 times. Equals, 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 equals. And then for the ninth equals, we're going to print equals new line. So then we've printed this line, and then we go through that line, and then that line, and then it's like, oh no, we're in the second third. And that is basically the code to print out the donut. And then down here, we're just doing a quick enter the length of the donut, and then running the function with the size that the user has inputted. I hope that is clear enough for you guys. It's kind of complicated, all of the nested for and if and else loops, but you know, it is really good practice for learning how Python goes through the loops and everything. So I'll just show the code again here in case you want to have a look at it yourself. It's fully commented, and of course if you don't understand anything, just pull one of us over in the lab and we can explain it to you again, because you know, this isn't exactly you know, super easy stuff. It might take you a while to get the hang of it. So yeah, I think those are the 2 questions for this week, and thank you for watching.